Hey guys, welcome back. Today I'm going to talk about how I did my wiring. This is all custom. There doesn't seem to be a standard way to do the wiring beyond the servos. So what I'm going to show you today will seem a little random and maybe a little disoriented because it is custom. I just took pictures of what I did and I'll walk through how I did it. But I like to start out here again, of course, with Gail's homepage and give anybody that's new a reference to his site. A lot of good information. This was where you should start. And of course, then I always recommend YouTube for those very good videos that are out there as well. So to get started with the wiring, come up here and go to how to sensor and more. And he has a list of all the sensors and some short little tutorials of how to get started with those. And I used those. They were good for me. Here's the one on the ultrasonic. I'm not going to go into great detail, just an overview so you know it's there. He shows you where to hook it up on the Nervo board and how to hook it up. Nice clean set of instructions here. You'll follow along with that. Works real great. Does the same with the PIR sensor. That's pretty straightforward. 3 wires to the Nervo board. Now I did cheat a little bit on this, right? Because this Nervo board has the 3 pins, male pins that are sticking up on the board, and I have an Arduino learner's kit that I had bought. It comes with those little jumpers, for the breadboard designing and stuff. So I took 3 of them that had a female on one end and a male on the other end, cut the male off, wired that end into the cable coming from my sensor, and that let me then just plug right into the PIR pins here. Made a nice simple install for me. Just something to keep in mind. The NeoPixel ring, he uses an Uno, walks through how to do it and everything. I use the Nano. It loads the same code and everything, so it's not a problem. But the Nano has a much smaller footprint, and believe me, space is limited inside your robot, so consider which one you want to use. I use the Nano. To connect, well, he doesn't have a lot of pictures here, or I don't think any pictures, to be honest, but he has a lot of good, useful information about how to hook it up, what software. Be sure to read on down into the comments, because some of the comments give even more clarification on another approach that works pretty well too. I'll make another video, of course, in the future on my Connect. Maybe I'll start with this as a base for that. And that'll bring us back to the home page again. So I'm going to drop this down and get it out of our way. And I'm going to start with what was readily available and proved to be very useful during the build. This diagram is available from the eMove website and many other places on the internet. Get it, use it. It's really, really helpful to see the relationship between the Nervo boards and all the servos that you're going to install. One thing that I did that I think was very handy was, as I installed servos, for example, the forearm. The forearm, you got all 5 servo motors for the fingers, and you got the wrist motion, right? And all that ends up hanging out the forearm, right? And to be connected up into the bicep. Well, they all squeeze through a little hole, and it's, once you put the covers on, it's awful hard to remember what lead went where. So I bought a numbering kit, a little label kit, wire label kit, and I took these numbers that were available off the card, and I put it on the lead of each servo. So when it's time to hook it up, that number's right there, and you can match number for number. Eliminated a potential problem. Let's just put it that way. It was a helpful little thing that I did. So I enjoyed that. But as far as wiring, that's about the extent of what's being offered is this diagram here. Well, what do you do with everything else, right? How do you get it where it needs to go? So I opened up an Excel spreadsheet, made a little simple diagram of how I did it. Now again, this is all custom. This is how I did it. You may not elect to use this at all, but at the same time, it may eliminate some fog for you as you start your build. I used a mini PC running Windows 10, and that was built by Blitzwolf, I believe was the name of the manufacturer. That's where I think this BW comes from. The model was a BW-MPC-1 mini PC. And it's real nice. Comes with built-in Wi-Fi. It's got several USB ports. It's a complete PC running Windows 10 Pro. So that's what I went with. And with that, I used a 7-inch monitor. Now this monitor is used a lot with, oh golly, I can't think of the name of the model, the little mini PC that not the Arduino, but the next scale up from that everybody uses, the Pi, the Raspberry Pi. There it is. Finally got it out. It's designed to work directly with a Raspberry Pi, but it works great with the mini computer. It even comes with the capability of touchscreen, but I didn't hook up my touchscreen with my trimmer, and that small screen. It wasn't going to work for me, so I didn't hook it up. So the computer then became the base of the smarts. But the truth is that the hub is kind of the USB hub, because that's where all your or most of your connections will go through. It really works out nice if you get that little 7 or 8 port hub, because it will send power and allow a direct connection to the computer all through the same lead, which really simplified the wiring. And you're short on room, so you want to take all those shortcuts you can. So based off that, here's my USB hub. You can see my green wires are all going out, and they're feeding the monitor, the camera. Now this is the camera in the eye. You can use one camera or you can use 2 cameras. It's optional. Gail says the second one's, unless you're really going to get into some fancy stuff, it's not really needed. I elected to go with 1 camera. And it feeds the nerval boards, the right nerval board and the left nerval board. And of course provides all the communications back to the computer through that same cable. The Nano that I used for the Pixel ring is also hooked to the USB. Again, gave me 1 connection, saved me a lot of hassle routing cables. And the connect down here at the bottom. For power, when I got into this, I was gonna, kind of follow along, do everything everybody else did. And there's a battery compartment. I bought the 6-volt battery. I bought the battery charger and all that. I bought everything in bulk up front. Right? And then as I started building this, I discovered I didn't have too much room. Also, the legs are not motorized. So Ralph is stationary in that respect. I pole mounted him, put him on a base, and then decided, that battery compartment, I could use that space for a lot better things. So I didn't use batteries at all. I went with 3 power supplies. You can see here I have a 5-volt feeding the USB hub. I have a 6-volt that goes to the left nervo and the right nervo to power all the servo motors. And I have a 12-volt power supply that feeds the computer, feeds the Connect, and feeds my speaker amplifier. You can see I installed 2 ultrasonic sensors. I did because I bought them. Really, I could have got by with one. Could have put it on one side of the robot chest, and I could have put the dummy filler in on the opposite side. But it looks neat with 2 sensors there anyway. So I put one sensor onto the right nervo, and I put the second ultrasonic sensor onto the left nervo. And of course the PIR sensor then is hooked to the left nervo card. The NeoPixel ring is of course then hooked to the Nano, fed back to the computer. Now on the computer, I used a wireless mouse and keyboard so that I don't have to worry about putting a cable into them. I just went with a little wireless adapter. And I have a mic headphone that connects via Bluetooth back to the computer. And that will let me have a good microphone to talk to Ralph so that I don't have any interference and problems with it. Eliminated another wire run and physical connection to the robot in any way. So, as you can see, it's kind of a good overview. It demonstrates what I did. I hope maybe this takes some of the cloud mystery away and augments the original servo printout design. It worked for me. I used this as a guide, made life simple. Now, with all that said, let's pop these down out of the way. And I'll walk you through, whoops, got the wrong one, guys. I'll walk you through some of my pictures here that I took, demonstrate what I did. Now, a lot of this wiring I did with the torso laying down on the bench. And that was for my convenience. It worked out good. It made it easy to put the PIR and the ultrasonic sensors in. And the NeoPixel ring went in nicely, laid on the bench. Then I just flipped him over, and routed the wires, and everything was great. But when it came time to put in the Connect, the Xbox Connect, it wasn't working well trying to put it in and route the wires. So that's when I set him up on the pole. You can see here I've got him pole mounted right here and bolted in on the pole. My son came over and helped me put him up there and drill that hole and get him all set. He was getting pretty hefty when I set him up there. And the second set of hands was real helpful. So I did appreciate him coming by. That let me then begin to route my wires off to connect. I've, physically mounted him in the front. And then you can see the black wire in the background there. Right, I routed it up through the torso and out into the back. You can see here where I had to cut open the lead because it had, 6-foot lead on it. Way too much wire to try to hide. So I was successful in cutting it back, because you're going to break the shield when you do that. But it worked out. I tested it before I mounted him back in. Everything worked. And with the short lead, I routed that cable to the back. Then there's the adapter that plugs into that Xbox that breaks out the USB and the power feed. And that I'm hiding in his back. And that let me go to the computer and, of course, route it to my 12-volt power supply. And it seems to be time for me to take a pill. So give me just a minute, guys. Okay, sorry about that little interruption. But back on track here now. This white wire from here is coming from my PIR sensor. And the other side I've got my wires coming in from my ultrasonics, fed out to the back so I could wire them. I did a little video on all that too. So you can go back and revisit that. Let me move him over here. Now, since I decided Ralph couldn't walk and I really needed that space where the battery was going to go, I elected to use my power supplies like I was telling you. So what I did was I found a nice little plastic container. It was clear in color to begin with, but I painted it white. And I got it as small as possible to mount my power supplies down in. And you can see I popped vent holes on the top and in the sides and everything to avoid any heat problems. And I routed the cable up the back of the pole. You can see it laying there. So that's where my power's coming from. Here's a little more detail. You can see the large power supply, that's my 6 volts because it's putting out some amperage. And then here's my 5-volt power supply and my 12-volt power supply. A little closer detail. Here are my 3 switches, my 5 volts, my 12 volts, and my 6 volts. So I didn't mount the switches up in his back. I mounted all my switches down in the box. Again, it simplified everything I had to do inside the robot. This is the battery compartment. Now it's empty, no battery. I got all this room to work with, which proved nice. I needed it. So here you can see I'm beginning to route wires. These are the 3 wires coming in from my PIR sensor and my 2 ultrasonics. They came in so I could wire them up. Now, my mini computer is mounted right here. But the mini computer comes in this nice little case that you can sit down on the desk with an on-off switch that you can push, and all the connections out where you can get it like you would expect a PC for an office environment or a desktop. Wouldn't fit. So I stripped it all out of the case, and I got the Wi-Fi antenna and remounted it inside the robot and everything. But as I'm putting it in, I discovered it's not going to fit. And the reason it wasn't going to fit was this is the pivot point right here, right where Ralph pivots from side to side. So if I mounted it in here, it was going to be hitting on the pivot points. Poor Ralph's not going to be able to move. So I measured and designed a little bracket to go in here with feet on it so that that base sits above this piece of his back, of his middle stomach, I guess I should say. That gave me a platform then to mount my little computer on and still allow Ralph to pivot. Eliminated that problem. And here you can begin to see some of my work. And we'll get more detail on this as we get going. Now, since this was a full-blown Windows computer, I started thinking, well, I don't want to be standing up trying to look at that little 7-inch screen while doing all this work. So I thought, I'll put an adapter in his back right here where I can take that screen connector and pop it free, and I can take a bigger connector that's on my desk and plug it in. And that would allow me to use a bigger screen and sit down and be comfortable and do my work. But since this picture, I've eliminated that little adapter, and I plugged that 7-inch HDMI connector straight into my PC board because I don't need it. And the reason I don't need it is I went with Windows Remote Desktop. It's built right into the operating system. Everything worked great. You go on YouTube, there's a dozen or more how to install, how to make Windows Remote Desktop work. It's simple, straightforward, a couple of clicks to set up the desktop you want to view. Go over to the computer where you want to work from, a couple of clicks to enable it there, and voila, you now have that desktop sitting in front of you. Works like a champ. Nice screen. I get to do everything I want. It's hooked up on my network, right? So I can still get out to the internet, everything. I'm really happy and pleased with that arrangement. Let's get to the next picture. Well, let me take it. Yeah, back it up here. Talk a little bit about this one. Let me blow him up. There we go. You can see this is the PC. Right, here's 4 USB ports built right into the motherboard. HDMI. Here's the speaker output. So everything, or a lot of what you need, is right there. Now, the push button is mounted up on this end of the computer, and of course, no way to get to it once it's buried in this back. So I ran a little cable out, and I mounted my little push button here, and that'll mount over here in this little switch hole, and I'll put a dummy plate on this side. This right here is my my speaker. You can see it come out here, and I split it out and plugged it into the board here. I'll get more detail on that in a little bit. But here's my little amplifier, and then here's my wires coming out that runs up to the neck to the ears. Now, my speakers in the ears are mono. The little board that they recommend was a mono board, so I just wired each speaker in parallel and made that install real simple. Just so you know, of course, if you're going to use stereo, you just use all four of your wires going up instead of two. That little white cable there is a 4-conductor cable. I just used two of them, cut the other two off. But that's a good idea. And that's where I placed it out of the way. Now, all these USB cables, 12 inches was too short. 18 inches was too long. or had a lot of slack in it. So you can see in the pictures here, a lot of places I just kind of swirled them around and moved them around and stuffed them in there where I could. But they're in there out of the way. But 18-inch ones, definitely probably what you're going to end up using. So let's see what the next picture has here. I keep having to move myself here. Let me get up here out of the way. There. Now, the main difference here, the reason for this picture, is see I'm putting the rest of his back in place. It's not bolted down, but I'm testing as I go, right? Making sure that I can get that piece in and everything's going to fit fine. It's kind of double checking as I go to make sure everything fits. Here's my little push button for my computer on off that'll mount in that hole. This will get a dummy plug. And of course I've got the battery cover made and it fits over here and we'll cover it. The USB, I'll hot glue that right onto the mid stomach, right across the back here. You can see this heavy gauge black and red wire. That's my 6 volts running up to my Nervo boards. This black and red wire here is coming off of my speakers. Right, so I get 12 volts for it. The computer, if I were to back this up, the power connector for the computer is right here. So I'll pull that plug down and route that wire out this direction to get power to it. The 5 volts I need for the USB strip come right off here, so I'll route that wire around to this side as well. And you see me doing that. Actually, you can see it right here. You can see the power cord coming here. Here's the one from the computer. My 12 volts coming down, my 6 volt cable coming down here. My speaker coming down here. And I begin attaching. This is an automobile trailer plug. It comes waterproof and everything like that. I took the waterproof gasket off because it was just tight, hard to work with, and I don't need it. So I took it off, made life easier for me. So I have my 6 volts coming up here on the red and the black, and my 5 volts is on the green and the yellow, and my 12 volts is on brown and white. So I brought them all in. You can see here where I shrink tubed and soldered everything together. And when I get done, I'll wrap it in the white tape like I did this cable down here, so that it blends in and doesn't stand out. It's not so gaudy looking. But I did leave. See here, I've got the black wire from my 6 volts hanging free here. And I have that for a reason, and I'll point that out in a minute. Now this is up high on his back. This is where the 7-inch monitor is mounted. Right? That's where you put your Nervo boards in. Well, all your ribbon cables and all your sensors and everything connect to those Nervo boards. If you look, you can see I printed the little case holders for the Nervo boards and glued them in place. And then I just snapped the Nervo boards down in place. They stay pretty well. I haven't had any problems with them popping free or anything. I bring my 6 volts in here, and then I jumper it across on this red and black wire to feed 6 volts to the other side, to the other Nervo board. Now if you go back, when I have a video about the Nervo boards and kind of intro on them and what I discovered about the wiring and how to build it, right? And when I did that, I told you, hey, maybe it's a good idea to mark where the red side of that ribbon is supposed to go. Make it nice and easy for you as you're doing it. So let's see if I can blow that up enough. You can just see on this one, you can just see that I've got a little red mark right there. That tells me that this red ribbon should end up on this side when I plug it in. That was helpful, especially when it was buried down in there. Made it easy to know I was getting it incorrect. So go back, study my Nervo board, look at some of those details. It might be helpful for you. Now, all this, man, all these ribbon cables and everything going in there became bulky and wire stuck up. I'm not a believer in taunt wiring. I think you should always leave yourself enough to make one repair. Okay, somewhere down the road you're going to need to make a repair, and if you cut your cables too close in length, then you're going to have to tear it all out and reroute a whole new cable and everything. Where if you leave a little bit of extra, you've got that room to play with. You can pull that cable around and make a repair and save a little work. But this became bulky. It was a problem. I can't remember his name right now, but one of the other guys on YouTube made an adapter for this 7-inch monitor. Turns out we ended up using the same monitor, and he made an adapter so that it fit right in here. And I asked him, and he was kind enough to send me the STL file. I made the adapter. It's, before I did any of the wiring, it snapped in, looked great, wonderful. But when I went to put it in, as I started my wiring, it was pressing down and compressing all this wiring. I wasn't comfortable with that. So, look at this picture. You can see that I built that out a little bit. I took his basic idea and I just made a box. I gave the adapter some depth so that it extended out further from the back. And now that slides in there and works perfect. It doesn't press the back of the 7-inch monitor into any of the wires in any way. Just a nice fit. So that's how I eliminated that tight wiring problem. You can see my little LEDs are on here. That indicates that I've got 6 volts going to those cards at the time I took this picture. Now, here's a little test I made. As I started putting in all these ribbon cables and hooking up all these servos, you run into the potential of doing something wrong, getting positive and negative backwards. You know, Murphy, he's always there. Something's going to go wrong. So what I did, here's my red wire and my black wire feeding my 6 volts up into Ralph's back, up to the nervo boards. So I set my 6-volt battery down here as a convenient source of power, and I set my multimeter up to read amps. Now, if you guys are kind of new to multimeters, if you're using it as a voltmeter, it's pretty straightforward. You put the red lead here where the V is, and you put the black lead in the common, and you're good to go. You know, you can select all the voltages you want. But if you're going to use it as an amp meter, you have to hook it up in series with the circuit. And you move those leads. The black one stays on the common. The red one moves over to the one marked for amperage. Then I took a jumper lead and I took my black lead, and here's my black jumper on the end of it, routed down under the table where you can't see it, and jumpered it onto the end of my meter. Well, I'm pointing at the wrong one. I'm sorry about that, guys. But you can see it here. The yellow one is on my. Oh, okay. Let's start from the other end and make it simpler. Start the battery. The positive side, I started out with the red lead to match my red probe, which then wires into the multimeter at the amp socket. I come out of the common, go out my black lead, come up to the end of the black lead, and here I used the yellow jumper, and I wired it in to the red wire, the positive side going up to the nervo boards. Now the negative side is much simpler. You come off the negative side of the battery and you just jumper it directly to the negative lead. The black one's going up to the nervo board. So now I've got the meter in series with the nervo board and everything that it's powering. So any amperage coming out of this battery now passes through my meter, and I get to see how much amperage I'm drawing. Well, I hooked it up, got it all set up, touched the red lead to the battery. I touched it, I didn't clip it. I touched it and held it there, and my meter jumped up to 6 amps. Well, nothing's turned on, nothing's working. Why am I getting 6 amps? Boy, I got off that sucker quick. It was a good indication I had a short. So I stopped and I backed up, and I went and I looked. I started looking at my boards here, and turns out this ribbon cable going up into the neck, feeding the servos up in the head, I had wired it backwards. I had put the red on the wrong side. And you think, well, Jim, how'd you do that? I mean, you labeled the damn socket. You got a red marker on the ribbon. You know, how in the world did you do that? Well, it wasn't easy, but I managed to do it. But the reason I found out later is because the way I rolled the cables over to plug them in, and I rolled it over and looked at it one way, and then when I took it out to put it together, without realizing it, I flipped it over. I squeezed it on, and the red ended up on this side instead of on the other side. If I blow this up, you'll see there's no red marking on that side. The red marker is on the other side. Well, I pulled that off. And the way I troubleshot this, guys, was first thing I did was I took the red and black jumper and pulled it off right here. That eliminated half of the nervo and the wiring on that side. It eliminated everything on that. What would that be? That would be his right hand nervo board. Okay, totally out of the circuit. Went back and I tapped my meter again. Still got 6 amps. So I knew that my short was on this left-hand servo board. So then what I did was I took all these ribbon cables and I popped them back out. I took them all out. Okay. Again, I tapped it and my 6 amps was gone. I put one cable in at a time, and as Murphy's law always is, the very last one I put in was the bad one. Well, that's when the 6 amps came back. So I looked close at that. That's when I discovered, oh, here's the red stripe on this side. Here's the red mark on the opposite side. So I, disassembled that connector, cut off 1/4 of an inch, where it, on the end of the ribbon cable, flipped it over and squeezed it back together and put it in. And when I did, then I got 0.09 amps. That's 90 milliamps. And why did I get 90 milliamps? Well, I've got some LEDs running and stuff up there on those boards, right? So it's not like it wasn't doing anything. But 90 milliamps in a static state with LEDs turned on, that's good reading. Good, not drawing 6 amps. Right? So once I got that reading, then, whoops, went the wrong way. Come on, mouse. Then I went back and I put this jumper back in and I tested it again. Right? Tapped that red lead on there and it stayed at 90 milliamps. So now I knew the other side was good as well. I suspected it would be since I'd found that 6 amp short. So there it is, all hooked up, sitting there idle. Of course, there's no 5/0 on the Nervo cards, so there's no commands being given to any of the outputs to power anything on a servo. So it's sitting static with just 6 volts on the cards and just 90 milliamp draw. I'm happy. It looks good. And now that I have it on all set up and on the pole, I told you earlier I didn't solder in that black wire. And the reason I didn't is because I'm going to continue this test. I'm about to mount the arms. And that means I'm going to have to do the ribbon cables out in the arm, right? I have to crimp those connectors on. The little adapter boards have got to go on. So I didn't solder that in so that I could put this amp meter in there into the circuit and I could test it just as I've done it here. Of course, I'll do that one ribbon cable at a time so that now it's more manageable. This picture really doesn't add much anything new. Let's just move on. I think I pointed out, oh yeah, the reason I have this picture in here, I wanted to point out a couple of things. These are the little adapter boards where the ribbon cable converts to the connectors where the servos plug on. Well, the bottom side of those adapter boards is the printed circuit is exposed. With it being inside here, the potential for a short circuit. Not now. That wouldn't make Murphy happy. But after I got him all assembled and right in the middle of my first showing when I'm going to show off the great work, one of those is going to short. So to prevent that, I took a piece of cardboard and I just cut out little pieces of cardboard and I hot glued them to the bottom of each one of those connectors. Why did I do that? Because they aren't permanently mounted anywhere. You'll see that coming up. Right here, as a matter of fact. So I started putting all these in. Lack of room. The space is tight. So I decided to let these things float. They're not going anywhere. They're well protected in the internal works of the robot. So I just let them float and kept them all very close. I had all my cables routed. Some of my servo cables, I put servo cable extensions on so that I could route that servo wire deeper into the robot and get all this wiring in one spot. So when it came time to hook it up to the Nervo board, I ended up making a lot of these little short cables. Now, this is about 2 inches long. You can see it is laying on the back of Ralph's covers. Right, so it's only about 2 inches long. This whole cable. There's a connector on each end. One of these goes, of course, down under the Nervo board. The other end goes right here in the adapter. Then that whole thing was just sitting in there. So I covered, like I said, I put a piece of cardboard and hot glued it up underneath each one of those so that the circuitry on the bottom side had no potential for a short. Well, I've got this up. Let's see if I can make this visible for you. If you look right here on the edge of this, you can see a little bit of the red fingernail polish. And again, go back and look at how I built this Nervo board, the video that I made on that, and you'll see more detail about that. But I marked that end, and I knew that's the end where the positive 6-volt power is supposed to go. And I point out the notch right here. And then on the mating connector, the notch is right here. So this cable is going to have to be flipped 180 degrees to plug that notch into that groove. And when you do, you'll see that this red stripe matches up with my red end. And I have a visual that everything's good. Another problem that I discovered that I wasn't really fond of with these adapter boards, maybe the next picture is a little clearer, yeah. These adapter boards, you can see the three 90-degree bends here, right? For power and signal for each servo. Well, this one's nice and long. This one's nice and long. This is a little stubby short one. And when you put that servo connector on, it's wobbly to say the least, not the most secure connection. And again, Murphy's going to get you. You're going to bury this thing down in the middle and you're going to rattle Ralph around and carry him around the house and bring him in, put him on display and try to get him to raise his arm, and it's not going to work because this connector came loose. So I put the connectors on and I got my hot glue gun out and I hot glued that baby. You can see it there. Okay. So, and I even, went down a little further onto the connector, the contacts itself, made sure that they're going to stay so that that connector had no chance of coming off. Now I've got this picture up. Let me show you where I mounted my Nano card. See if I can back this up here enough. Yeah. Here you can see this is the bracket. This is the two tips for the bracket that for the battery cover. Well, then it's got the stem that goes into his back, and then you screw it down into the torso, right? And that's the little bracket. Well, that little bracket, I used it, and here's my little Nano board, and I bought this little Breakout board, handiest little thing to have. I bought it off the internet. It's a Nano Breakout board, and it brings out, you plug the Nano into the socket, and it breaks all the pins out into these screw terminals. And so it was real easy to plug in my Pixel board and power and everything, and gave me a nice place to be able to glue that onto that vertical support. So it's right there between. You can see there's a Nervo board, there's a Nervo board, there's my Nano mounted right there. Worked out nice for me. So you got to find space, guys. It's there. You just got to find it. Here again, you can see it mounted in there. This is the little amplifier. This is the one that Gail has on his bill of materials on the website. So I bought it. And again, it has those male pins sticking up for connectors. I got more of my little learner's kit breadboard cablings with the female ends. They plugged right in, and I soldered my cable to it. Right? The yellow went to the yellow and the red went to the red, and my white went to both blacks because they were both grounds. And then here's the end that plugs in to my computer. Everything was hunky-dory. Just a good picture of the ears. They went in pretty good. And remember, I told you already that I just wired the pins from this speaker across to the other one and ran a common cable down and plugged it into the board. And they went into these two terminals here. Hooked up pretty easy. I minimized the number of wires through that neck by doing all this. I ended up with one little 4-conductor cable for the ears, of which I cut 2 off because I only needed 2 wires. I ran a extension on the servos, one servo, and ran it down through the neck because it needed to go onto a different adapter board than the one that's mounted in the head. The one in the head runs the eyes. The one for the jaw is on a different adapter board as part of the neck, if I remember right. So it was where you're going to mount this stuff. So I put an extender on it and ran it back down into his back cavity and left that little adapter board down there. Minimized my wiring through the neck. Speaking of the eyes, this is inside his head before I put the skull on. You can see here, remember I was telling you earlier, I bought the wire markers and I put the number of each servo right on the cable end. So when it was time to plug them into this adapter board, their numbers are right here. And so I just matched number for number, right? And I knew I was plugging it into the right spot. And then I super glued this adapter board right on top of the jaw, I think it is. No, the swivel, the head swivel, the servo that makes the head swivel back and forth. Another picture of it. Again, remember I'm certain that one of these was going to come loose, so I super glued those. I liberally use super glue as I routed cables. I super glued, tacked them in place as I routed them. And now it's time for my arms. I've got both arms built. I've discovered that this is really a two-man job, mounting this arm. My son came over and I held the arm while he put the arm to the shoulder, put that plates in place. I'm shorter than Ralph, okay, which made it hard to begin with, trying to work over my head. But just holding the weight up, that left him free to use both his arms to put the pieces together. So I've got him mechanically joined now. You can see here's all the fingers and the wrist wiring hanging out here, and here's the ribbon cables and the bicep and the shoulder servo wiring hanging out here. That's my next task. Here's a better shot of it. You can see it better here. Again, here's my power supply with that black lead free where I can insert my amp meter during my test. So when I hook this shoulder ribbon cable up and plug in the servos there, then I'll hook the battery back up. Well, in this case, I can just turn on the power supply, right? And see if I get a surge in current. Once that's done, then I can take the ribbon cable from my fingers, hook everything up, see if I get a surge. No surge, then I can move over to the next arm, do the same thing. This is up close where the arm mounts to the shoulder. Is everything coming out of the shoulder and ready for the arm. You can see the ribbon cable for the fingers passing down into the bicep. You can see the servo lead for the elbow coming up from the bicep. And then I have the shoulder rotate and pivot coming in from the shoulder, from those two internal servos. And then this external servo that mounts on the back of his arm, that's where the potentiometer and of course the servo lead come in. And I'm going to feed them in from the back side here to the gap. I'll feed them in to here. This ribbon cable then will get cut, the adapter card put on, and will remain right here with those three cables plugged into it. The ribbon cable will then continue on down for me to do the other arm. That was the best way I saw to do this, guys. If you find a nicer way, do it. If I were going to change anything, I would look at how I pass these wires through these joints. I guess it works. Got a lot of guys that got robots out there moving arms, but I don't know. I think I might have looked at that differently. But Gail does a great job. It works. It's great, and I'm definitely not going to complain. I might change things if I ever built one again, but I'm happy. That kind of wraps it up, guys. It's all custom. There's nobody else probably that did it the same way I did. So look what they did. Look what I did. Hopefully you'll see this before you get too deep into your whole build and get some ideas and do some pre-planning. All right, guys. So this will be the last video I do on the mechanical build. I'm not going to come back and show you how I hook both these arms up. I don't think that's going to add much value. So it'll be a while, I guess, before my next video. And from now on, I'm going to start focusing on my robot lab and some of the programming and how I'm bringing him to life. I'll bring on the sensors and I'll show you how I get the servos moving and so forth. It'll be a learning experience for me, and I'm happy to share it with you. Hope it's been meaningful. Catch you next time when I'm programming. See you later, guys.